Okay, so let's start with this third panel of the day. Welcome everyone to ONEedgeDay 2022. This is the first session you've joined so far. This specific panel is going to be about the really cool technology integrations we've carried out during the execution of the ONEedge project since 2019 till the final version, which will be released actually tomorrow. So we have a really nice group of people today. Christian and Gert will be joining us live. You'll see them in a second. And because of they are in a different time zone, Keith from SUSE and Anup from Oracle will be joining us with a pre-recorded video. But in any case, all four are really amazing presentations, all of them touching on different aspects, different technologies and cloud providers that we've been collaborating with during this period. And in the case of Threefold, as you'll see, really nice collaboration that we are envisioning for the near future. So thank you all for attending this session, and thank you special thanks to the speakers. Christian, the floor is yours.
Okay, hello everyone. Well, I'm Christian González. I'm senior cloud engineer at OpenNebula system, and I'm in charge of the Firecracker integration within OpenNebula. So today I'm going to give you a quick overview of what Firecracker is and how we have integrated it within OpenNebula. So first, let's start with how Firecracker defines itself in their web page. So basically, they define themselves as an open source virtualization technology, which allows you to manage and create a secure multi-tenant container and function-based services. So basically, it is a virtualization technology with a very specific purpose, which is create this virtualization environment for this kind of all loads only. So they introduces this micro VM concept, which basically are just normal VMs, but with a very reduced set of features for achieving this goal of lightweight, secure, and fast virtualization. So for those of you who are more familiar with virtualization in the Linux environment, probably you have been using QEMU at some point. So basically, Firecracker is another virtual machine monitor, another VMM, which is an alternative to QEMU for this kind of scenarios. So QEMU is like a default or a very general purpose virtualization technology, which allow you to configure different scenarios using different driver and virtualizing different components. And Firecracker doesn't aim to provide this flexibility. They just want to provide a specific micro VM with some reduced set of feature for running this kind of loads in a multi-tenant environment for container-like loads. So they are focused on providing some very secure and very lightweight virtualization technology for this specific purpose. Also, they are an open source technology maintained by AWS. So it has all the benefits that open source provide. Well, you can go through the source code. Everybody can check how things are working, provide some bug fixes or even feature. We have contributed some feature while we integrated Firecracker within OpenNebula, and also it is used within these AWS serverless services like AWS Fargate and Lambda. So it is used in one of the biggest clouds of the world in production environments. So it also provides some confidence into this project. So this is an image just to show you how this Firecracker microVMs fits within the OpenNebula environment. Before including this support, we already have support for normal virtual machine with VMware and KVM. We already supported system containers with LXC, and now we have these micro VMs also, which provide just more flexibility to our users to deploy their loads in the way that fits better their use cases. So which work have we done for including this into OpenNebula? In OpenNebula, there are like 4 main drivers or 4 main ways of interacting with the virtualization load, which basically are these storage drivers, networking drivers, monitoring and virtualization drivers. So we implemented all of them for Firecracker, taking into account Firecracker limitations. So for example, for storage, Firecracker only support file-based storage. So we need to take care of that while developing the drivers. Also for networking, they only support Linux Blitz-based networking. So we took care of that too. And once we have Firecracker already integrated within OpenNebula, we added some things on top of that. For example, the VNC access. Firecracker doesn't provide VNC access for microVMs, which and we thought that accessing remotely these VMs via VNC, which is kind of one of the most used protocol for remote access, will be useful, and we already supported for all of the other hypervisor. So we implemented this on top of Firecracker. So the users can interact with Firecracker microVMs the same they've been doing with normal VMs or system containers. So once we had Firecracker fully supported within OpenNebula, we start deploying Firecracker microVM. So what do you need for deploying a Firecracker microVM? Basically, we need an uncompressed kernel image, which you can achieve by just building the whatever version of the Linux kernel that you want to use. You build that and you get this binary file that you will use it for deploying these Firecracker microVMs. But also we need some file system image, and generating or getting this file system image is not an easy task. So we wanted to make this easy for our users. So we took advantage of how image container images are built. If you take a look at the Open Container Initiative definition of this standard container bundle, which basically are a container image, it has 2 main artifacts. One of them is this configuration data, which is used for deploying the container. Another one is this container root file system, which is exactly what we needed. So we decided to integrate Docker Hub within OpenNebula. Docker Hub is like one of probably the world's largest library for container images. So there are a lot of container images for different projects and with different configuration there. They have around 170 officially supported images. So we decided to take advantage of all the work that they have been doing and make it easier to our customer or user to use those images. So we integrated within OpenNebula. So with a couple of clicks, a user will be able to just select which image they want to use and download it within their cloud and start deploying this microVM like very easily, just with a couple of clicks. So adding this Docker Hub and Firecracker couple into the OpenNebula landscape, we kind of support like all the ways that you might run containerized deployment. We already have support for system container for LXC or LXD that we are deprecating now. We also have this Kubernetes appliance, which is certified, and this K3s appliance too. So by adding this Docker Hub and Firecracker, we add a new way of running containerized loads within your cloud in a more secure way, because Firecracker will add this extra virtualization layer, which will increase the security of your loads without penalizing the performance, because they are very focusing on that. So you have like all these ways for managing containers within your OpenNebula cloud. So the end user will be able to choose which of them will fit better their use cases. So well, here you have some of the use cases that we've been deploying or testing while the Firecracker integration. So For example, you have a talk here regarding how to use OpenNebula as an alternative to Kubernetes for running container as a service directly. Instead of managing the container with Kubernetes, you can manage directly with OpenNebula as Firecracker microVMs. Also, you can use Mini1, a tool for automate the installation of OpenNebula to deploy these Firecracker clouds on the edge, or run some serverless computing like at the edge using this Docker Hub integration and Firecracker microVMs. So if you want to give it a try, there are a couple of URLs here that you can use. You can try the latest feature, which will be included in this 6.4 beta, which I think is going to be released today or tomorrow. And well, you can use this Mini1 to install OpenNebula in a couple of minutes and play with it if you are interested. And well, thanks to the European Commission for the trust in our project. And that's all. If you have any doubt or whatever.